Hi everyone, in this video we're going to combine your knowledge of the graphs of a to the x and a to the minus x with your knowledge of transformations of functions so that we can graph even more exponential functions. So let's start with the example f of x equals 3 to the x. So from the last video we know that the domain of this function is all real numbers. We know it goes through the point 0, 1, and we know it's increasing as x gets large. And as x goes to negative infinity, we have this horizontal asymptote at y equals 0. So this is what the graph of 3 to the x looks like. Now I want to graph g of x equals 3 to the x plus 1. So you could think of this as just 3 is still our base, but instead of plugging in x, we're plugging in x plus 1. So this is just like doing f of x plus 1. We know from our knowledge of transformations that when we replace x with x plus 1 in the expression, this gives us a shift left by 1. So I can take each of my points and shift it left by 1. So 0, 1 will now go to negative 1, 0. 1, 3 will now go to 0, 3. 2, 9 will now go to 1, 9. And all of these points just shift over to the left by 1. So our new graph will still have that horizontal asymptote, but it will look more like this. Shifted to the left by 1. Now if I want to graph h of x equals 3 to the x minus 2, well, this is just like doing f of x first and subtracting 2 off of it. We know from our unit on transformations that this shifts the graph down by 2. So I can take all the points on my original graph and just move them down by 2. So this point would go down by 2, this point would go down by 2, this point would go down by 2, and the horizontal asymptote that used to be at 0 will now be at negative y equals negative 2. So the new graph will look something like this. Here's another example. To do k of x equals minus 3 to the x, we're basically doing 3 to the x and just putting a minus sign in front of it. So this is the same as negative f of x. And we know that this means to reflect over the x-axis. So I take my original graph and I reflect it over the x-axis. So instead of 0, 1, I have 0, negative 1. Instead of 1, 3, I have 1, negative 3. Instead of 2, 9, I have 2, negative 9. And I still have this horizontal asymptote at 0, at y equals 0. Oops, a little bit of an inaccurate picture, but this one's k of x equals negative 3 to the x. So one thing you'll notice about this one is the domain is the same, but the range is now all negative numbers. We can make similar observations about the orange graph. The domain is the same, but the range, now we get some negative numbers because our horizontal asymptote shifts down by 2. So the range will now be negative 2 to infinity instead. Let's do this final example, j of x equals 3 to the minus x. So here, instead of plugging in x, we're plugging in negative x. So we could think of this one as f of negative x. And from what we know about transformations, this is a reflection over the y-axis. So from our original intercept, that point's not going to change, but 1, 3 will now become negative 1, 3. 2, 9 will now become negative 2, 9. And this entire asymptote will now switch to this side. This pink graph is exactly what we'd expect because we know that a to the minus x has an asymptote at 0, has an intercept at 0, 1, and as the x values get large, we approach the asymptote of y equals 0, and it's decreasing. But we saw it now as a reflection over the y-axis, but also as the example that we saw in the last video, a to the minus x. So this is the basic strategy. Once you're presented with an equation, a function that looks like a to the x with some transformations, just determine what those transformations are. There might be a shift to the left, a shift to the right, a shift up, or a shift down. And then from your graph, you can determine all kinds of new information. For example, in this orange graph, the shift down by 2 meant that our new horizontal asymptote was at y equals minus 2. And so our new range was -2 to infinity. So I hope that this helps, and it's sort of a cool way to integrate a lot of the knowledge that you already have. In the next couple videos, we'll move on to discussing logs, and we'll see how the graphs of the log functions are related to the graphs of the exponential functions.